Hi, and welcome to the spatial analysis component of the RMRS Raster Utility. In this little video, we're going to go over some of the tools that I've developed to do a wide range of spatial analyses. And to illustrate this, we're going to use a digital elevation model located in California. Now, one of the first things with the RMRS Raster Utility, you'll notice that there are not as many tools as what I'm showing that first come up. In order to load those tools, you must use the customization functionality of ArcMap. Originally, I had got some funding to create help documentation for these tools, and at that time I generated a lot of help documentation regarding the tools that I had developed. Since then, I've created many more tools and added to it, and so most of these tools I'm going to show today, you're going to have to customize and add in there. I'm not going to be able to go show all of the tools, but I'm going to hit on some highlights of some common ones, and then you can explore the rest of them and look through some of the other tutorials and workshops that I've put together that will highlight some of that functionality. But to begin with, most of the tools for doing the spatial modeling are found under fall under the Raster Utilities set of commands. And if we come into the Raster Utility, we can see there's quite an array of different tools. And if we want to add one of those tools to the toolbar itself, we simply can grab it and drag it and put it wherever we want. I already have a photo analysis one, so I'm going to just drop it off to the side. And once we've added some of those tools in, we can then go ahead and use them just as if they were just part of ARC. So to highlight some of the functionality here, I'm going to use some very basic tools. I'm going to look at what the arithmetic analysis does. Here, if we click the arithmetic button, we can see we can input a digital elevation model. We could input a value if we wanted to. And we could, in this case, for our second layer, it could be a digital elevation model, or again, it could be a value. Let's say we wanted to convert our elevation model from meters to feet. So there's 3.281 feet per meter, so we can type in 3.281 and use the multiplying sign, and we can give an output name to it. When we hit execute, what we'll have almost instantaneously is a new raster surface that instead of being in meters is now in feet. We can look at this raster surface, and it looks basically the same, especially if I display it differently, but the values are now in feet as opposed to meters. I'll go ahead and change the symbology here. Now, one of the things to note here is that this tool actually creates function raster datasets. So these datasets do not exist on disk. They are just a transformation of the values. But we can use it just as if it's a regular raster dataset. So I can click in here and click on the cell value, and I can see JKL has a value of that, of almost 7,000 feet above sea level. I can also show it so all visible layers, and we can see what the difference in that value is. We can see here JKL has a value of almost 6,500 feet, whereas DEM 30 has a value of almost 2,000 meters. So we can see that the analysis has worked correctly and it's doing the mathematics on it. Now, with any of these spatial analysis tools, we can have inputs that are rasters, we can have inputs that are function raster datasets, and we can have inputs that are vector type datasets. There's a whole array of tools. So we can do things like mathematical transformations where we take the natural log of a cell value or do some sort of square rooting or power analysis. We can do logical analyses, booleans, ands, ors, greater than, less than, so on and so forth. Go ahead and close out of that. We can do remapping, conditional analyses, focal sample, in which we're actually going to take a sample around and do a focal analysis, so we can put whatever shaping we want. And most of these tools, or many of these tools, are named similar to what Esri would name them within their spatial analyst. There's a departure here, though, within what Esri does and what I do. My tools work on multi-band raster surfaces. They also work in this function modeling processing construct, and they do not require a spatial analyst license or ARC info type license for that matter. Additionally, I have built-in tools that are unique in that, for example, if we want to do a focal analysis, we can actually calculate entropy and angular second moment. We can look at all sorts of different values in terms of unique medians and modes and variants. And these tools run very quickly, whether it's a mosaic raster dataset or a local raster dataset, and so on and so forth. So to kind of give a quick overview of some of these, we have local I'm going to go through some of them and just give off some names and kind of briefly describe what they do. So we have like a focal band analysis. And if we think about this in a time series approach, we can think about quantifying means and standard deviations and so on and so forth for each cell in the Z direction as opposed to in the X and Y direction. Similarly, we can do local statistics where we want to calculate on a cell value what's the average, what's the maximum band, or where does the cell come from a maximum band, and so on. We can resample rasters, change their granular size, remap rasters, create constants rasters so that we can do multiplication with any other surface. We can set null datas to value. We can actually set the null values here, set values to no data. So we have lots of functionality here with basic raster manipulation, combining rasters, performing linear transformation, extracting bands, flipping, rotating, aggregating cells. If we wanted to go, say, from a 10 meter to 30 meter, we can tell whether we want to get the mean for all those values. We can calculate slopes and aspects, eastings and northings. We can shift rasters, perform clip analyses, where we extract out the raster boundary given some polygon feature. Convert pixel types from being floating points, say, to U characters so that we can reduce the overall size of the raster data set. We can rescale rasters, create composites, merge rasters together, create mosaics. We can actually tile those mosaics. We can create gray level co-occurrence matrix. Now these are gray level co-occurrence matrix calculated at the finest resolution that you can get, meaning that categories are not aggregated up. They are whatever values are on the landscape. We can calculate landscape metrics. For those that are used to frag stats, we can do a focal window type of analysis and calculate a wide range of landscape metrics. We can do it for regions. We can do it for edges. We can do patch statistics where we look at entropy, angular second movement, sums, means. We can do circles and rectangles, and so on and so forth. We can do tassel cap, NDVI. We can even bring images to a common radiometric scale. And I've got a couple of papers out about this new technique that you can use, but this works really well to take two Landsat images acquired on 2 different days representing the same phenology and making them into one raster surface that has a common radiometric scale. All sorts of zonal statistics on multi-band raster data sets, and this is not as zonal statistics. So if you have overlapping polygons, this directly addresses how to calculate those analyses for overlapping polygons, and it does it across multiple bands for many, many different metrics. There's some tools for photo analysis. We've got a paper, Joe St. Peter and I, related to doing photo analyses and MODIS, and you can look at those tools through here. Region grouping, a delivered cost model. Again, there's a paper that you can look at and check out the delivered cost workshop that I have on the site, and you can get a better idea what you do with that one. Build raster attribute tables and function modeling, which is an older rendition of batch processing. So there's a lot of functionality within this raster analysis, and there's some other tools that we can look at. So come back and check out our sampling tools and then our statistical modeling tools, which when combined together create a very powerful set of functionalities within the GIS to do a wider range of analytical types of analyses using spatial data. Thank you much.